This video is hypothesis testing, the null and alternate hypothesis, part 4. So we're going to start learning how to use the calculator to actually run the test. We talked about how to write the null and alternate hypothesis. We talked about types of errors that you can have. We talked about conclusions based off of a p-value. So now I'm going to show you how to find the p-value with the calculator. So when you are using the calculator, first you have to decide which test you want to run. There are 3 that we're going to start with: a z-test, a t-test, and a one-prop z-test. We use a z-test if we're testing a mean and the population standard deviation is known. Then we'll use a z-test. We'll have the choice of data or stats. Use statistics if they've given you the sample mean and the population standard deviation and the number in the sample, all of that. If they give you the data in a list, choose data. We use a t-test if we are testing a mean and we know the sample standard deviation, but we do not know the population standard deviation. And it's the same kind of deal. And we use a one-prop z-test if we're testing a proportion. Now to get there, we go to Stat, arrow right to Test. Z-test is number 1, t-test is number 2, one-prop z-test is number 5. Now a couple other things. You will need to, the first thing you will need to put in, whether it's data or stats, is you need to put in the null. So what does the null equal? So if we said mu equals 20 is the null, then you would put 20 here. Okay. Then fill in your statistics, and then you have to choose the statement that matches your alternate statement. So is your alternate statement greater than, is it less than, or is it not equal to? And you choose that. Then you'll hit calculate. Once you hit calculate, then you will have a screen that will give you quite a bit of data. The first thing you want to do is you want to make sure that the top statement on the screen, once you run this test, matches your alternate statement. And if it does, then you know you did it right. So then you're going to see a Z or a T, and that is called a test statistic. We need it for our homework. You can use it to help decide whether to reject or fail to reject the null. However, we're not going to use the test statistic method, but you will be asked for test statistic in the homework. So just make sure that you put whatever number is the Z or the T, that's the number you put in for the test stat. The next number is a p-value. It will say p, not to be confused with p-hat for the proportion test. It will just say p. That number will be a number between 0 and 1, and it's the probability that your sample results would occur again, given that the null is true. So how likely it is that that would occur. That is what your p is. That's what we're looking for. You're looking for the p-value. And then you will remember, if the p is low, the null must go. So if the p is low, we reject the null. If it's not low, we fail to reject. So let's just look at a few examples. I think, we have 2 examples here that we'll start with. So example 1, years of education. A social scientist suspects that the mean number of years of education for adults in a certain large city is greater than 12. She surveys 100 adults and finds that the sample mean number of years is 12.98. Assume that the population standard deviation is 3 years. Test this claim. So we need to write a few things. The first thing is figure out what the claim is. What are we testing? So the social scientist suspects that the mean number of years of education in a certain large city is greater than 12. So we will use that. We'll use that to help us write our null and our alternate statement. So we are testing a mean. So we're going to use mu. Remember that the null is always equals. Now, the alternate statement usually goes with the claim. In this case, we're saying that it is greater than 12 is our claim. That's our alternate statement. And since the numbers have to match, we're assuming that the mean equals 12 would be our null. So this is what's on trial, that the mean equals 12. So then we have some data collected. We took a sample of 100 adults and we found the sample mean was 12.98, and then we're assuming the population standard deviation is 3. So now we need to decide which test do we run. Which test? Okay, well, since we're testing a mean, it should either be a Z or a T test, and we know the population standard deviation, so that must mean we're going to run a Z test. So when you run the Z test, it's going to ask you for a few things. We're just going to go ahead and write these things down. This is how you show your work. It's going to ask you for the null. The null equals 12. It's going to ask you for sigma. Sigma is 3. It's going to ask you for X bar. X bar is the sample mean, which is 12.98. It's going to ask you for N. N is the sample size, which is 100. It's going to ask you for the alternate statement. The alternate statement is that it is greater than the null. And then you're going to choose calculate. Okay, so I'm going to pull up the calculator here, and I'm going to say stat. I'm going to go to test. I'm going to choose a Z test, which is number 1. I'm going to choose statistics because we didn't have raw data, we have statistics. And null we said was 12. Sigma we said was 3. X bar is our sample mean, which is 12.98. N is 100. And then our alternate statement is greater, so make sure you highlight greater and hit enter. And then go to calculate and hit enter. Now notice what it gives us. It gives us mu is greater than 12. Make sure that matches the alternate statement. It does. Okay, so most likely we entered everything incorrectly. So this number here, this is our test stat. Z is our test statistic. And again, while this is useful for a specific method, for what we call the critical value method of determining whether to reject or fail to reject the null, we're not going to focus on that method. So the only thing you really need this for is for our homework. When they say, what is the test stat? The test stat is 3.267. Just pay attention to how they want you to round. This number here, 5.44169112 E negative 4, that is our p-value. That's what we're interested in. We're interested in the p-value. That's what we're going to write down. X bar 12.98, just make sure that's what you meant to type in. N equals 100, make sure that's what you meant to type in. Okay, so going back to write out what we found. Okay, so I'm going to write my p-value. Now, my p-value was 5.44, etc., e to the negative 4. So that means I need to move my decimal 1, 2, 3, 4 places to the left, and I get 0.0000544, etc. I want to round to the 4th decimal place, so the 4 tells the 5 to stay a 5. So my p-value is 0.0005. Now we need to find our significance level. That's what we consider unusual. And it looks like this particular problem does not have a significance level. So if it doesn't have a significance level, assume your significance level is 0.05 if they don't give you one. Now you need to compare these two numbers. Always put the p-value first and the significance level second, and fill in the blank for this statement. Is 0.0005 less than 0.05, or is it greater than 0.05? It is less. So if it's less, that means the p is low and the null must go, so we're going to reject the null. If the p-value is less than the significance level, less than or equal to the significance level, we reject the null. We reject the null. And then we have to make a conclusion statement. So it's a sentence, similar to how we wrote sentences for confidence level, confidence intervals rather. So here's the basic template. you write there is or is not. So you would fill in the blank there. Enough evidence to support the claim that, and then you need to specify what the claim was. The claim was that the mean number of education years for adults is greater than 12. I'm running out of space. Okay, so we're always going to say there is enough evidence to support the claim, or there is not enough evidence to support the claim, and be sure to specify what the claim is. Okay, it's not just enough to say that we support or fail to support the claim. Okay, so if you reject the null, check out what's happening. We're rejecting the null. We're saying this is false. We rejected that. So if that is false, and only one of these statements can be true, then that must mean that the mean is greater than 12. So that means that there is enough evidence to support the claim that the mean number of education years for adults in a certain large city is greater than 12. Now, so when we reject the null, there is enough evidence to support the claim. If we fail to reject the null, there is not enough evidence to support the claim. Okay, so this is an example 2. A pretest and post-test were given to workshop attendees. The pretest score average was 24, and the researchers want to know whether the post-test score is significantly different from the pretest score. They sampled 50 tests and found that the sample mean was 24.8. Assume the population standard deviation is 1.2. Use a significance level of 0.01. Why don't you try this one and pause the video and then come back and I'll go through the answer. Okay, so for this one, we want to know if the post-test score is significantly different than the pre-test, which was 24. So we're going to assume, to begin with, that it's equal to 24, and then the alternate statement, we're going to test the claim that the mean is different, not equal to 24. Now, real quick, if our alternate statement is less than, we're going to say that that is a left-tailed. If it is greater than, we're going to say that's right-tailed. And then if it's not equal to 2, we're going to say that's two-tailed. I just saw that that was in the homework, and I just wanted to make sure that I went into that real quick. So left-tailed is less than, right-tailed is greater than, two-tailed is not equal to. Okay, we're going to run a z-test. All right. Here's the data we'd put in. We'd put in the null is 24, sigma, which they said was the population standard deviation, which is why we're running the z-test, is 1.2. The sample mean is 24.8, n is 50, and we put in that it's not equal to the null for the alternate statement. That's what you're putting into your calculator when you go to stat test, choose z-test number 1. The p-value you get is 2.43 e to the negative 6, which is 0.000002, which rounds to 0, and that's less than our significance level of 0.01. And if it's lower, we reject the null. If we reject the null, there is enough evidence to support the claim that post-test scores are significantly different than the pre-test score of 24. Okay, so this ends this section. Don't worry, when we go into the next section of videos, we're going to do a whole lot more examples of this type. Okay? Let me know if you have questions.